All right, so our astronomy class jumps off with some challenging equations, the small angle equation being certainly one of them, probably, I would say, one of the most difficult equations in the course. And so this practice quiz is usually challenging. So I just want to walk through these 5 questions with you and show you how to solve them. I encourage you to solve them on your own first, so you can kind of struggle with it. There's something good about struggling through these. It's really the best way to learn some of these math skills, but I don't want you to get frustrated. Okay, so let's take a look. I'm going to write right at the top here the small angle equation itself. Okay, so we have theta, the angle, equals 206,265 times diameter over distance. All right, and depending on what we're given, we might need to rearrange this equation, and that's where the challenge comes in with needing to know the algebra. So for example, you might need to rearrange this equation to solve for the diameter or to solve for the distance. So you'll see, I'll write that out and then you can use those equations to help you. So in this case it asks, what is the distance? So I'm going to try to solve for distance here. So let's write distance equals question mark. What is the distance of an object that has an angular diameter? Whenever you see angular, you know we're talking about angular size. So that's theta equals 100 arc seconds. And a linear diameter of 50 meters. So the diameter is capital D equals 50 meters. So these are the things we're given. We're given theta, we're given capital D, and we need to find lowercase d. So I can plug in those values, but it doesn't do me any good unless I need to solve for lowercase d. And that's where the algebra comes in. So if you're familiar with the steps of algebra, to solve for lowercase d, to get it by itself, you would multiply both sides by lowercase d, and that cancels it out of the denominator. So you'd end up with d on this side, d theta equals 206,265 times capital D. And then to get diameter by itself, you divide both sides. So I'll write this out. So I would multiply both sides. I'd end up with the distance times theta equals 206,265 times diameter. Okay, and now I need to see that canceled out the distance on the right hand side. Now I need to get distance by itself, so I'll divide both sides by theta. Divide both sides by theta. Right, and that canceled it out here. And I end up with distance by itself. Now, to be totally honest with you, I'm not super interested in your ability to do this algebra. Like what I'm most interested in is your understanding of the astronomy. But to understand the astronomy, you need to get a sense of how these relationships are related, and they're related through these mathematical ways. So here's the point though, anytime you need to find the distance when you're given the angle and diameter, you will use the same equation. The distance equals 206,265 times diameter over theta. Okay, that's the equation when you're solving for distance. You have the equation up here. This is when you're solving for the angle. Okay, and then you could use this equation anytime you're solving for distance. So if you want to write that on your equation sheet, you could. That'd be fine. Okay, so let's plug in the values. I have a capital D of 50 and a theta of 100. So I'm going to get an answer, which is that the distance equals 206,265 times 50 meters divided by 100 arc seconds. And the units are all set up so that those units don't really matter in this case. So let's put that into our calculator here. Okay, 206,265 times 50 divided by 100. And I end up with an answer of 103. Uh-oh, I lost it here. 132. Now, you might be wondering, like, how many of these digits do I have to put in my answer? Well, when I've set up these practice quizzes and our regular quizzes and tests, it's set to round, usually to about the last, well, what would I say? I've tried to set it so that you can put basically as many digits as you want. So if you put 0.5, you would still be marked correct. If you rounded this to 103130, you would still be marked correct. But in general, just put as many decimal points as you can, but you don't have to go crazy. Like if you put 3 or 4 decimals, you've done more than enough. So you do here 103.132.5, and you submit it, and that's your answer. Now we know the answer is in meters because I've said that in the question, so you do not have to put meters here at all. All right, so this will be a little easier because this one's asking us for distance again. What is the distance in meters of an object that has an angular diameter of 30 arc seconds and a linear diameter of 10 centimeters? So here we go. I'm being given theta equals 30 arc seconds. The linear diameter, capital D, is 10 centimeters. Oh, so this is a little tricky. This is 10 centimeters, right? But it's asking for the distance in meters. So if the distance is going to be in meters, we got to keep all the units the same here. So that 10 centimeters is going to be 0.1 meters. You want to make sure that your distance and your linear diameter are in the same units. Okay, so and then I'm asked to solve for the distance. Well, this is the same situation where I'm given angle and diameter and I have to find the distance. So I can use this equation from question 1. Same equation. I don't have to do any more algebra. I can just use that same equation. 206,265 times diameter over the angle. All right, and I'll plug in my values. 206,265 times 0.1 divided by 30. So let's see what we get there. 206,265 times 0.1 divided by 30. 687.55. 687.55. Alrighty. Okay. Let's go to question 3. Now it asks us to find the linear diameter. Which is capital D. Object has an angular diameter of 10 arc seconds and a distance of 50,000 meters. So again, I'm going to write down what it tells me here. Theta is 10 arc seconds. The distance is 50,000 meters. Okay, so those units, meters, are the same as what I want for my diameter. And I'm trying to solve for capital D now. So again, I'm going to have to do some algebra. I'm going to start with my initial equation, except now I want to rearrange it to solve for diameter. Okay, so the first step is I need to get rid of this distance. I'm dividing by distance, so to get rid of it, I need to multiply both sides by distance. So I'm doing some algebra here. I have theta times D equals 206,265 times the diameter. Now again, once we do this once and we get another version of this equation, you don't have to keep doing this algebra. It's just something we do once and we get the new rearranged equation. Okay, diameter, divide both sides now by 206,265 to cancel that out. Right? Okay, it's going to cancel off that side, but if I do it to the right side, I got to do it to the left. 206,265. So my equation, if I were to rewrite it now, would be, I'm just going to put it in a box here momentarily. So diameter equals theta times distance divided by 206,265. So this is the third version of the equation. Right? I've got 3 variations on the exact same equation. Each one is arranged to solve for the variable I care about. Okay, so in this case, I can just plug in the values now. So the diameter is going to equal 10 arc seconds times the distance of 50,000 divided by 206,265. All right, kind of running out of space, but let's plug that in. So 10 times 50,000 divided by 206,265, and I end up with 2.4. Now this is a perfect example where, see, this number just goes on and on and on, right? So how much of this do I really need to write? So 2.42 maybe. Let's see, how far does it go? 2.424066. Okay, so really you're not going to need to go beyond a few decimals. All right, and if you round it too much, you might be marked wrong. Like if you rounded this to 2, you might be marked wrong. So just give a few decimals, but you don't need to write like 10 or 20 of them. You'll still be marked right if you do, but you just don't need to. Okay, let's go to the questions 4 and 5. All right, so let's take a look. Now I need those equations again, which you hopefully have written down in your equation sheet. So how many meters across is a road sign that has an angular size of 120 arc seconds and is 1 kilometer away? So now I got to figure out which one's distance, which one's diameter. So this is clearly my angular size. It's 1 kilometer away, so this is the distance. And it's asking me how many meters across it is, like how big it is. That would be like the diameter. All right, and so let me write these out here. So I'm given theta equals 120 arc seconds. The distance is 1 kilometer, so I need to put that into meters. So that is the same units, 1,000 meters. And then the question is, what's my diameter? So again, for my own sake, I just put this up here. Theta equals 206,265 diameter over distance. Now, you've maybe written down that equation. I'm just going to remind myself it's times that divided by that. So the equation then is the diameter equals theta times the distance divided by 206,265. So if you're really comfortable with the algebra, you would just do this in your head. But if you are rusty at algebra, then just have the rearranged version, this equation, written on your equation sheet. Okay, and then you can use that on the quizzes and tests. Like I think that's totally fine. I don't consider that cheating in any sort of way. This is not a course in algebra, it's a course in astronomy. So I'm sorry that there's any math, but there's way more math than this in the reality, in the true study of astronomy. Okay, so 120 times 1,000 divided, okay, so we can just plug in the values here. 120 times 1,000 divided by 206,265. Alrighty. 120 times 1,000 divided by 206,265. Again, we get all these digits. I'm just going to do 0.582. See, I'm rounding that value to 2. And that's plenty of accuracy. 0.582. All right, last one. What's the angular diameter, theta, of an object that has a linear diameter, capital D, and a distance of 3 kilometers? So what do I have here? Capital D equals 5 meters. Distance is 3 kilometers. That's 3,000 meters. And theta equals question mark. You can use the given equation. Theta equals 206,265 times diameter over distance, which is the same as saying 206,265 times 5 meters over 3,000. And what do I end up with? We've got 206,265 times 5 divided by 3,000, 343.78. 343.78. Now let me say, if you round it and you get marked wrong, just let me know and I'll give you those points back. Because if it's just for rounding error, obviously I'll give you credit back. But just make sure you're putting a couple decimals and you'll be fine. Okay, so I hope that helps as you're struggling through some of this math. But once you get the hang of it, you'll see that it's not so bad. Okay,